Good morning. Hello, welcome, and let's go ahead and get started with our presentation. Thank you for joining us. Today we're going to be focused on OutSystems and how to simplify your data platform for performance using Snowflake and Fivetran to decrease complexity and increase insight. My name is Melanie Marks. I am the Director of Demand Generation for Snowflake Computing, and I will be your moderator today. First, I would like to very much thank our sponsor and technology partner, Fivetran. Fivetran fully automated connectors sync data from cloud applications, databases, event logs, and more into your data warehouse. Fivetran integrations are built for teams who need data centralized but don't want to spend time maintaining their own pipeline or ETL systems. And hosting today's presentation is Snowflake Computing. Snowflake provides the only data warehouse built for the cloud, one designed to deliver the performance, simplicity, and concurrency needed to solve today's data analytics challenges. Today's presentation will be largely focused on our featured customer, OutSystems, and we'll discuss the OutSystems story, their strategic analytics initiatives, and really how they got where they are today as a truly data-driven organization. And before we begin, let's go over a few housekeeping items. So I wanted to make sure that everyone knows that we'll be engaging. We'd love for you to engage with us as well, our audience, through our question and answer session at the end of today's presentation. So please use the Q&A widget that you see at the bottom of the webinar platform, and we will be taking as many questions as possible. And if we don't address your questions directly, we'll be sure to follow up with you individually. Also, at the end of our presentation, each presenter's contact details will be shared, and we'll be sending around the recording after. So today's presentation obviously is being recorded, and we will be available following the presentation. And we also have some great resources for you. So I wanted to make sure that you have a look at our resource center directly through the On24 platform, including featured data sheets, ebooks, and analyst reports. All right, so now I'd like to welcome today's presenters. Ross Perez is the Director of Product Marketing for Snowflake. Ross is charged with leading the discussion about analytics, big data, and cloud data warehousing among Snowflake's customers, partners, and the marketplace as a whole. And Taylor Brown. Taylor is the co-founder of Fivetran, and he currently leads sales, marketing, and partnership teams for Fivetran. And welcome Gonzalo Fonseca, Senior Architect for the OutSystems digital platform, as he has led the initiative to revise the corporate data and analytics strategy at OutSystems, and you'll be hearing all about that. Okay, let's go ahead and get started. I'm going to pass the presentation over to Ross from Snowflake. Ross, take it away.
Well, thank you, Mel, and thank you so much, everyone, for attending today and for wanting to know a little bit more about Snowflake and Fivetran. We're really happy to have you here today, and we're excited to have OutSystems tell you a little bit about their experience using our tools together. Some of you may be completely new to Snowflake, and so for those of you, I just wanted to briefly go over what Snowflake is, what we do, and how we can serve you. First of all, Snowflake is a data warehouse. So we're a tool that you would use to store your data, to analyze your data, transform it, and generally start finding the answers and insight that your organization needs. Now, Snowflake is the first completely new data warehouse architecture on the market in over 30 years. In other words, we didn't create Snowflake from a previous data warehouse and then lift it to the cloud and make some tweaks. We actually built Snowflake from the very beginning to be its own standalone tool that is completely new from the ground up. Because we were able to do that, we have some capabilities that might be a little bit unfamiliar to those of you who have been using traditional data warehouses that use previous data warehouse architectures. First of all, Snowflake is a complete SQL database. This means that you can query Snowflake with SQL, unlike big data systems like Hadoop. And because of that, you can do the sorts of things that you'd expect to be able to do with the data warehouse with Snowflake. It's also ACID compliant. You can do the edits, updates, deletes, inserts that you need to do to be able to work with your data and transform your data and change it. You can use Snowflake like a data warehouse because it is a data warehouse. Snowflake also allows zero management. This means when you load your data, there's no indexing, tuning, or management or knobs to turn. You can simply load your data and then Snowflake does the rest for you. You can also host all of your data. If you have semi-structured data like JSON or XML, you can load that data into Snowflake into a variant type column and then use dot notation to be able to query it with SQL as well. This means that you can use all of that data that your business is collecting no matter what the format is. And this in combination with FiveStrand is actually extremely powerful as well. So we'll hear a little bit more about that as we get down the road. You can also host all of your users. This is a huge one for data warehouses these days, and people are having a lot of problems serving the needs of their organization. These antiquated data warehouse architectures that have been around for 30 years weren't meant to serve the entire company with data. But Snowflake is very uniquely suited to be able to serve all of your users with independent compute resources that we call virtual warehouses. And I'll talk about that a little bit more in a second. Lastly, because Snowflake was built in the cloud, it means that you only pay for what you use. If you're not using a compute resource, then you're not paying for it. If you're not storing data, you're not paying for the amount of storage that you could possibly use in the future. Instead of a fixed upfront fee, you pay as you go. So how is all of this possible? Well, the simple answer is architecture. Snowflake was built with a completely new architecture that from the ground up that's completely different from the previous shared disk and shared nothing architectures. Fundamentally, there are many differences, but since we don't have too much time, the basic thing that I want you to take away from this is that instead of having only a single cluster as your unit of scale, with Snowflake you can have multiple clusters. How do we do this? Well, first of all, Snowflake was built around centralized storage. So whenever you have, when you set up your Snowflake account, you'll have a centralized storage location where all of your databases will live. And on top of that, you can have virtual compute resources dedicated to different activities. So if you have loading, ad hoc analytics, and development all going on at the same time, you can create these separate virtual compute resources that will serve each one of those needs without interacting with one another. This means that the data that you're loading into Snowflake will have no effect on the ad hoc analytics that someone's performing at the same time. And we can do this, again, because we were architected for the cloud, because we built Snowflake from the very beginning to be able to scale up a compute resource and scale down for whatever purposes you may have. And then on top of all of this, this is abstracted through the Snowflake Services layer. So we have a very nice web UI, and we have all of the built-in security and metadata management that you need and the optimization that you want without having to have you actually go in and turn all of those knobs and take care of all of the infrastructure. Snowflake does all of that for you. It's a data warehouse as a service. And of course, this isn't what we like to lead with, but it's so important for many organizations today. Cost is so important to be able to manage. Instead of paying for that fixed level of capacity and then going through periods where you're not using it, with Snowflake you can adapt on demand to the peaks and valleys in the demand for your database and be able to significantly cut your expenditures on your data warehouse, even compared to data warehouses in the cloud. We have customers that are spending anywhere from a half to a third of the amount that they were spending on their previous cloud data warehouse because they're not paying a fixed fee. They're only paying for the compute that they're actually using. So with that, I'd love to pass it on to Taylor Brown from FiveTran, who's going to talk a little bit about how FiveTran works and how it integrates with Snowflake as well.
Awesome. Thanks so much, Ross. Good morning, everyone. As Ross alluded, I'm Taylor Brown, co-founder of FiveTran. And before I dive in to tell more about specifically FiveTran, I'd like to just take a second to look more at the larger space of data replication, or ETL. So as Ross alluded to, things have changed in the last few years in terms of data warehousing, and as a result, there have been some pretty significant changes as well to the way that companies are loading data into these newer warehouses. So if you look here on the left side of the screen, there's what we like to call the classic ETL. This is the idea where customers would extract data from their various data sources, they'd clean it, transform it, then they'd aggregate and model it, then load it into their warehouse, and then visualize it. And the key thing to look at here is the aggregate and model step is happening prior to loading the data into the warehouse. And the reason for this was that up until a few years ago, the cost of data storage is much higher, and also the databases were not as powerful as they are today. And so as a result, companies needed to pre-aggregate this data and put it into more of a cube in the warehouse, and then essentially run their visualizations were also not in the cloud. What has changed in the last few years is that the cost of data storage has gone down tremendously. There's really fantastic columnar data warehouses like Snowflake, and so that has resulted in a fairly large change in the overall space. So as we see it now, the modern ELT workflow, as we like to call it, is more of a setup where you extract the data from the data sources, you clean it, transform it, load it in a more holistic way. So you're essentially loading everything you have in the source into the warehouse into more of what we'd like to call a data lake. And this is one of the reasons that FiveStrand and Snowflake work so well together, because of their separated compute from store, where you can load everything into their storage S3 layer, and then you can access it through all their various virtual warehouses at any time. And then in this model, you aggregate and model the data inside the SQL layer, inside the superfast data warehouse, using SQL, which now every analyst knows and understands, and then you visualize by only shipping the results to the browser using tools like Looker, things like that. So as you can see, FiveStrand automatically or basically handles steps 1 through 4 with very little setup and management on top of that. So to dive in a little bit deeper just about the actual integrations and types of categories of data connectors that FiveStrand offers, we connect to cloud APIs, databases. We also have cloud storage and file uploads. We can pull various events. You can send events directly to us. And then also we support some cloud reports. And we load them into your data warehouse. So we're essentially the pipeline between your various data sources and your data warehouse. To dive in more specifically, here's just a quick list of all the different data sources that we support. From the cloud applications, everything from Asana to Zopum. Salesforce is really, Salesforce or Marketo or NetSuite are some of the more popular ones, but we're constantly adding to this list. In terms of databases, we have everything from Aurora to SQL Server, Oracle, MySQL. In terms of cloud storage, Amazon S3, Google Cloud Storage, SFTP, and a number of other ones coming there. File uploads, CSVs. We actually have a CSV upload directly in the system, so you can upload right from your browser right into your warehouse. Google Sheets and JSON, and then Google Analytics, Segment, Snowplow, webhooks, and then a few different cloud reports like AdWords and Bing, Facebook, things like that. I think the way we like to think about it is we're really a toolkit for analysts to very easily get all of their data into their warehouse without a whole lot of setup and management. And then finally, just a few perks of using FiveStrand is that kind of separate us from many of the more classic ETL tools is that there's really a 5-minute setup. There's zero maintenance, and you have full control over it because all the data gets loaded into your warehouse. And the steps of actually setting things up are you would say you're going to set up a Salesforce account, you'd go through, you'd authenticate your Salesforce account, and then you're essentially done. We would pull all the historical data, clean and transform it, load it, and then continue to update that continuously, every hour or so. So that's a quick deep dive into FiveStrand. At this point, I'm going to hand things over to Gonzalo from OutSystems and let him tell you a little bit more about how they're using both of these tools.
Okay, thank you. Hi, everyone. As they mentioned, I'm going to try to share a little bit about our experience at transforming how we deal with data and analytics at OutSystems, and the role that both Snowflake and FiveStrand have played on that. Just to start, and to give you a little bit more context, let me talk a little bit about OutSystems. So we are a leading provider of low-code or high productivity in the high productivity platform space. We have a visual development platform that allows you to create mobile or web applications that have which are very easy to integrate with other existing systems. So we're basically a DevOps supporting stack, and this has led us to having a very distinct ecosystem, which is mostly comprised of applications that were built with our own platform. Those are normally complemented with SaaS systems that we use for commodity problems like marketing automation, CRM, billing, etc. And as we were in a kind of startup context for a long time, our culture is a culture based on a lot of engineering principles and a lot of engineering people. So what this has caused is throughout the years, and with a lack of guidelines at the corporate level, we found ourselves with a lot of departmental level solutions for data and analytics. So when you get people that are very resourceful and technically savvy, they will go about their business and do that on their own. As the company grew, also as a result of the fact that we're in a very fastly expanding market today, as the company grew quite exponentially in the past few years, we realized that we needed to address data and analytics at the corporate level. So we had this growing realization that if we wanted to get truly meaningful insights from the data we had internally, as well as being able to get more data from our current sources and new sources that we're not really exploring, we needed to have a better standardization of both what the metrics are, how they should be processed, and also the supporting stack should be centralized rather than have it distributed throughout the company. So in 2013, we had a first attempt at trying to address this. Like I said, our ecosystem, it's mostly apps built with our own platform. We also have a number of SaaS systems, and our idea was to try to show the value of consolidating data from all of these sources in a single repository that would be easily queryable, okay? And so we set about creating a data pipeline that would perform data extraction from SaaS systems using custom-built connectors with our own technology. They would then dump the data into a staging database, and we had ETL processes built in Pentao to move that data into our data repository. Okay, this was a SQL Server database hosted on Amazon. We also had separate Pentao processes doing ETL, traditional ETL, as Taylor just mentioned, going into the databases that support our own applications and moving that data to our repository. We then did exploration with Qlik, just SQL querying. We also have a lot of visualization built with our own applications. And we have, well, recently, in the past 2 years, we created a data science capability within the company, which uses a lot of our processing and modeling. We also had a separate pipelines to handle streams, mostly the Qlik stream from our website. Now, kind of rudimentary as this was, it served us rather well. We were able to get a lot of value from the fact that we had all of this raw data in one place. Of course, it also made it very evident that we had data quality issues, data duplication, data latency issues between different systems. And the stack itself was time-consuming. We had a lot of manpower put into keeping the wheels turning. And it also had scalability issues. So this was all managed by us. It was quite time-consuming. And so from that situation, we realized we had a lot of different challenges. We had business challenges where we needed to be able to give insights to a very fast-growing business. We also had to be able to break the silos that we had been created within the organization from a data point of view. And like I said, we started hitting the wall as far as technical limitations in the stack that we used. We sat down to try to draw a vision of where we wanted to go. So we definitely wanted to have a corporate level data infrastructure that would follow a kind of big data approach, although we're not really big data per se. So we failed the volume test, I would say, of the 3 or 4 V's of big data. We also realized that we needed to put some governance and specific skills around data, and that we needed to have a data team within our company to be able to help and support business units in setting up the metrics, exploring the data, and getting the best insights from them. And that we also definitely had data quality issues that ideally would be solved in source systems, but that we also had to have processes in place where we are looking at the data to make sure that we know what is the best quality data and make the decisions based on that. So the design principles we tried to follow were, we wanted a data lake type approach where we would be able to leverage both structured, since we have a lot of databases, and semi-structured data. We wanted to be able to explore a lot of JSON telemetry information that we have from the website, of course, from our own product, from sources that we're not really exploring at the time. And so this approach of semi-structured data allows us to apply a schema on read of the data. So we have a lot of raw information, and then we model it while we extract it. You don't have to worry about modeling the data beforehand. So having the flexibility of adding a lot of raw data was something that we definitely wanted. Something else that was very clear in our minds was we wanted a fully managed operation. We don't want to worry about scaling. We don't want to worry about scaling both at the storage level and the processing level. We also wanted to make sure that whatever solution we would adopt, we wouldn't face a user adoption issue. So SQL-like query capabilities on top of the repository we would use is definitely a must, because as Ross mentioned, the data community has a familiarity with SQL that is definitely something that we wanted to leverage. And we also didn't want to have any lock-in to the vendors we selected. And, I skipped one, sorry. The point-in-time analysis was we wanted to have a simple way of snapshotting our data and being able to go back and look at the data at given points in time and not have to worry about archiving strategies or what would be the impact in our storage. We wanted to have this as simple as possible. So as far as implementation goes, we looked at 2 options. One would be to make sure that we would create the data pipelining and also the repository on a piece-by-piece approach, where we would pick and choose from the best providers in the market, and we would have control of the stack and be able to, if necessary, unplug a particular data pipeline component and plug a different one, or change repository. Or we looked at, well, not so much data lake as a service, I would call it more a data and analytics platform as a service, where you have an out-of-the-box solution that basically gives you connectivity to source systems to do the data extraction. It gives you the storage, and it also gives you the analytics capability. Well, we're having this conversation today, so obviously we went with the approach of building our own stack piece by piece. We felt, having tried some of these data and analytics platform as a service providers, we felt that it didn't give us the flexibility that we wanted. We found several limitations, and looking at the ongoing trials we had with different data pipelining and repository providers, we definitely felt that it was a much better proposition in terms of value, in terms of the direction to move forward in the future. So on the data collection or extraction part, what we were looking for were providers that gave us connectors for the SaaS that we use. Things like Salesforce, Marketo, NetSuite, Intercom, Zendesk, etc. We also wanted to make sure that they had connectors for the databases that we use internally to support our own applications, of course, that would be able to handle stream data and have support for a variety of warehouse destinations. And right from the start, we knew that Snowflake would be an option here, so we were looking for support. We looked at very different providers. We looked at creating this ourselves using pieces from the AWS stack. We looked at Stitch, Matillion, etc., and obviously FiveStrand. Oh, considering our decision vectors, we ended up with a very clear choice of FiveStrand. The model that they use, the way they had, it fit very well with exactly what we were looking. We were looking for a data pipeline, and that's exactly what FiveStrand provides, with a really simple approach. It is really pretty much just configuration, one-time configuration. And it has the support for Snowflake. It just completely, it's kind of a black box, but it's of ETL complexity, and it just delivers on the goods. As far as our data storage and querying, so we wanted, as I mentioned before, support for structured and semi-structured data. We also wanted to make sure that it would be open for exploration by different BI tools. We have a couple of them that we use internally. I've mentioned Click. We also wanted to make sure that we would be able to access it from our own applications through SQL querying. Again, querying capability, SQL compatibility are really important to be able to have our data analysts and predictive analysts work on top of the data. And we wanted it to be really simple. We didn't want them to go out and have to learn a different technology on top of SQL to be able to do preparation on the data. And we were obviously looking for scalability for both storage and computing power. Again, we looked at different providers. We looked at that Hadoop, but the complexity and the price point and the fact that we don't really have the volume to justify it just drove us away from it rather quickly. We also looked at using Amazon S3 with Presto, but again, that's exactly the type of complexity in doing data preparation that we wanted to avoid. Amazon Redshift, we had piloted it for a long time. We still use it. We are very big AWS customers, and we use it internally to support a lot of things. So there was a lot of familiarity with the tool. But in the end, the lack of support for semi-structured data, as well as the poor or not as flexible scaling model, were very big decision factors, and it led us to Snowflake as our provider of choice. So today, we have a very similar approach to what we had initially, but we have offloaded both the data extraction and the data repository and exploration to FiveStrand and Snowflake. So all of our SaaS systems, the information is being collected through FiveStrand. All of our internal applications, FiveStrand is getting the data from the databases directly, pushing that data into Snowflake periodically, and we're doing the data exploration with the same tools that we had before. So it was a very seamless, just a change of connection strings, and it was a very seamless transition there. Just going into a little bit more detail on what we've envisioned initially. So diving a little bit into the data lake itself, we envisioned having different maturity stages for the data. We have a staging area or a staging layer, which is the raw data that FiveStrand collects. We then have a data layer where we do a little bit of sanitization and beautification. We do name changes on tables and so on to make the data easier to explore. We would then have an information layer where we would probably structure unstructured data for specific use cases that we know we would like to explore that data in. And then finally, an aggregation layer where we would have a typical data warehouse or data mart within Snowflake to provide to different business units with aggregations that would give them the kind of metrics that they're looking for. Okay, and this is another thing that we really like with Snowflake is the ability to, within one single repository, have all of these data maturity layers and the ease with which we can move the data around, transform it, and that was a very big point for us, and it still is. And the fact that, I don't know if I mentioned it before, but before we had at least one person dedicated kind of full-time throughout the year for the data extraction part. And I would say that it's no longer an issue. We don't really have anyone dedicated to that anymore. It's really just running by itself, a very low maintenance process. We did have envisioned initially that, so this is for a more classical data analysis approach. We would like also to have a more real-time processing capability. So we're looking at having our streams come in and follow two different pipelines, one leading into the data lake and the Snowflake repository, and another one to a stream processing capability. We haven't reached that stage yet. So where we are today is here. We haven't really created any data warehouse or data mart yet. We're looking at exposing the data to the different business units on a structured model, but they're exploring it themselves for the time being, as we're still collecting information about what metrics would be most relevant for different units. And when we don't have the real-time processing in place. What we do have is all of the stream data is then being loaded in a mix between FiveStrand and Snowflake from their own S3 capabilities into our repository. As far as execution timeline, this was also a very important factor when deciding the providers. So it was beginning of August last year that we decided we're going to move forward. We're going to revamp our analytics platform. We did a lot of analysis. We decided what would be the criteria for selection, what were our main goals, and it took us until about the end of November to settle on providers. It was about that time that we had a meeting with our CEO, and he said, you guys need to have this ready before Christmas. And, a few nervous looks around the table. But the fact is, on the 23rd of December, so less than 1 month after, we had pretty much all that we were aiming to achieve live. So we had set up FiveStrand to connect to all of our primary data sources. The data extraction was working. We had the data flowing into Snowflake. We had Snowflake connected to our analytics tools, to our BI tools, and we had the two first layers of our data maturity in place. And it was very shortly after that, so about 2 weeks later, we concluded the handover or the switchover of all of our internal analytics community from our previous stack to the data lake. And we started issuing the first management reports, mostly around sales and marketing, from data in the data lake. And it was, well, 6 months, less than 6 months execution timeline, which we couldn't really have done it had we chosen a different stack than the one we have today. In closing, I would just like to share a few lessons that we learned during our process. The first one is the ability to have a quick minimum viable product of what you're trying to achieve is crucial when selling your idea and getting momentum and support. So the fact that we were able to create a POC combining FiveStrand and Snowflake really allowed us to show the value of using this type of strategy, which is still, I don't think, all that common. I do believe that we're going to be seeing more and more companies switching to this kind of approach because it really makes sense on all levels. So it's important to try to do that setup initially. Something that we struggled with, we were very, and also by our nature, we're very technical guys, so we are not really data guys. We were very concerned with getting the technical setup ready in time, and we overlooked the fact that we would need to staff a data team with people that are more data savvy than we are. And it took us at least twice as long to be able to hire the first person to our data team than it took us for the entire technical implementation. So if you're looking for a revamp like we did, don't overlook the people side, okay? Data is both technical and today you still need people with the insight to be able to extract the best insights. Something else that we also learned is that an analytics and reporting stack is not a data integration stack. So if you look at the capabilities, the data replication capabilities that FiveStrand provides, it's very easy to have the temptation to say, okay, if I have a very efficient way to extract data from all of my different systems and put them in a single repository, and that single repository, as in the case of Snowflake, is actually a SQL database, then I'm going to use that data to feed back into my own applications. I don't have to go directly to Marketo to get the data. I will go to my data repository. Well, we have been doing that, but there are technical limitations. This is not really a stack that is fully tailored to suit to that problem. And just saying, be careful, especially as we have felt a lot of pressure from business to go down that path. And something that we did struggle with, as I said, we have data quality issues that have not been fully addressed. We kind of, also in the sake of time, saving time, we gave access to our data lake to the different business units before actually consolidating specific data marts for each one of them. So having access to the raw data without fully understanding it and understanding what are the potential pitfalls will lead to incorrect analysis. So we felt that perhaps we skipped one step. We should have probably, in at least some different and some specific business areas, we should probably have covered the full maturity of the data before providing it to business. And I think that covers all of that I wanted to share. So, Melanie, shall we go to the Q&A part?
Absolutely. Thank you so much, Gonzalo, and thank you to Ross and Taylor as well. So yeah, let's dive right into our Q&A. Don't be shy. Please do submit your questions. We will be taking them directly through the Q&A widget that you'll see, and we do have a number of questions that have been sent in along the way. So I think, Taylor, this first one could be for you here. How are the tables structured in the information layer? Are you using a dimensional model? Or no, I'm sorry, Gonzalo, probably in your use case here.
Okay. Well, no. I would say the dimensional model would be on the stage that we're missing, the aggregation one. What we have today in our information layer, imagine that you have a JSON, you have a source that produces JSON that's essentially unstructured data. Not every single payload of JSON has the exact same structure. Some fields may be missing. They might have drill downs in some of them that are not present in others. So what we do is, for very specific use cases, we are structuring that data, also to make it a little bit easier for people that are not really that technologically savvy to be able to explore the data. Although we found Snowflake's JSON processing capabilities to be awesome. That was definitely one of the big factors for our decision. Bridging the gap for business users is not that simple. So we have a few cases where we're doing that. I hope that answers the question.
Yep, absolutely, Gonzalo. And we have another one for you as well, asking you to go into some more detail on the difference between the data integration stack and analytics and reporting stack.
Okay, so we're trying to address two different things internally. At one point, we thought we could do both things with the same solution. So we would use the combination of FiveStrand and Snowflake as a data replication pipeline that would then be consumed in different systems. So let me just give you an example. Let's imagine that I have all my Salesforce data, so my CRM data is made available in Snowflake. Now I have an application where I need to get information about a specific customer. I can either go to my CRM system, which would probably imply an API call, or I can query my repository. Now, Snowflake is excellent at handling complex queries, managing a lot of data, going over millions of records and giving you the results in a very short amount of time. It's not excellent when doing, the performance doesn't really scale if you're just trying to get one specific record. It's going to be slower than your regular transactional database. And it didn't give us the level of performance that users were used to. So we've kind of dropped that idea for the time being, and we're looking at different proper data integration and data replication across systems. So we're trying a different approach.
Okay, thanks, Gonzalo. Ross, I actually have a question for you. Gonzalo was discussing his requirements for being able to query semi-structured data. How do you at Snowflake query semi-structured data?
Yeah, thanks, Mel. Well, so Snowflake is able to allow you to work with semi-structured data in a couple of ways. You can load any semi-structured data, if it's XML or JSON or Avro or Parquet, into what's called a variant type column. And so imagine you have a JSON file with a bunch of nested columns, and you load that file into Snowflake. Well, all of those individual files are going to be loaded as rows within Snowflake in the variant type column. And then when you click on that variant type column and kind of drill down into it, all of the nested structure of the data is still visible to you and usable. And then to query the data and to flatten it if you need to, you can use dot notation to reference any object or value within that nested JSON and pull out any individual values or any series of values that you need to be able to turn it into a relational, more standard relational columns and rows type of format. And, you know, of course, FiveStrand is kind of a big piece of this too. I mean, you can do all of this within Snowflake, and then you can also, you know, reference third-party tools if you need to be able to transform your data if it's in transit, and also to transform it down the road if you prefer to do that as well. But all of it can be accomplished within Snowflake as well.
Thanks, Ross.
This is Taylor from FiveStrand. I was just going to jump in to say that FiveStrand automatically loads JSON data into Snowflake as variant type. So, you know, for customers who are loading in their semi-structured data through a FiveStrand system, we will automatically set it up in Snowflake in the variant type, so it's easy to then work with in the ways that Ross explained.
Thanks, Taylor. I do have a question for you also. Does FiveStrand support a sandbox or a test account?
Yes, we actually, with every account, we offer a sandbox account to load, set up all of your integrations to load into a sandbox warehouse if you want to run, in a testing environment. That's totally included as part of the plan.
Okay, great. Consolo, another specific question. Are you using views to provide the structure for the JSON in the information layer, or are you converting them to physical tables?
Well, we have tried both approaches, to be honest, and we are currently using tables. We are converting them into physical tables. The reason why we're doing that is because we're really not that concerned at this point with storage, and it was actually, we found it to be somewhat more efficient in terms of performance. So we do that as a one-time operation as we are loading the data regularly, and that's at least the approach we're using today. But both of them are very, very good. We started with the views approach and then decided to change it, but we're also actually considering going back because it's simpler to maintain a view than having the process to do the creation of physical tables.
All right, excellent. Ross, another question for you. Can Snowflake automatically respond to queuing?
So one of the features that's really powerful in Snowflake actually is the ability to set up what's called a multi-cluster warehouse. And so what this means is if you have, say, a business intelligence tool, and there's dozens of people that are querying Snowflake through this tool at the same time, in a traditional data warehouse, eventually you start to get queuing where the resources of the data warehouse are completely exhausted by the demand for data. Now, in Snowflake, you'll also get queuing, but you can enable what's called a multi-cluster warehouse that will automatically spin up new clusters to deal with this additional demand. So without having to do any intervention or changing the size of your warehouse or anything like that, Snowflake will just serve the need of these additional people. And then when demand subsides again, it'll settle back down to the level it was at before, the minimum level that you set within Snowflake. And so this is something that really isn't possible with any other data warehouse, and again is kind of made possible by Snowflake's architecture, because you can just respond to that demand automatically without having to go in there and manually scale up to serve this.
All right, excellent. Consolo, another question for you. You spoke about large amounts of data, but the question is around any background that you'd like to share in terms of challenges moving larger amounts of data across the cloud to and from Snowflake, and your experience there.
Okay, so, well, like I said, we don't have big data volumes, okay? So I actually don't know how large our repository in Snowflake is today, but it's in the gigabytes, not terabytes, well, maybe terabytes, but not petabytes kind of dimension for sure. And we also have, well, as I believe Ross has mentioned, Snowflake is AWS based, and so are we. So in fact, although this isn't a Hadoop cluster type of data locality, it's not that separate. We chose a Snowflake location that was the same as our own location to have as much data locality as possible. And the biggest volumes of data that we probably moved were when we did the initial loading of our existing databases through FiveStrand. And honestly, we didn't really have any challenges there. All of the rest of rather large bulk loads, we are handling those through the S3 loading mechanism that either FiveStrand or Snowflake provide. And again, we haven't had any challenges there. So, I don't know, I'd say those are good news, but that's it.
Anything to add on to that, Ross? Maybe some of the other Snowflake customers that do have incredibly large amounts of volume.
Yeah, well, I don't want to kind of mention specific customers, but whenever somebody asks about the amount of volume that you can use with Snowflake, we have multiple customers that are dealing with petabytes of data. And, the interesting thing about, again, I hate to keep on repeating this, but, truthfully, the architecture of Snowflake, because it's built in the cloud, because it's referencing Amazon S3 in the background and Amazon EC2 for compute, our level of scalability is really essentially, almost unlimited when you think about the amount of data and that you can store and that you can query within Snowflake. So, we're leveraging the largest cloud, the most reliable cloud platform to serve really large amounts of data that our customers are asking us to look at. And because this is a kind of a new architecture that we built from the beginning, it was designed to handle these petabyte scale loads and work within them without having to do too much modification or work or maintenance and management that has traditionally been associated with really large data volumes.
And how about you, Taylor, on the FiveTran side? Anything to add?
Yeah, I mean, FiveTran's really, set up to sync, most of the larger data sizes that we're pulling from are coming from like S3 or coming from a database. And we've spent a tremendous amount of time optimizing how we do that initial historical load of data, and then continue to update. We actually read off of the logs from most of the databases, so it's extremely efficient for large data volumes. We're also doing incremental loads for every one of our syncs, so we're not doing any extraneous extra loading of data. So the combination of those make it easy for us to scale up to large data volumes.
Perfect.
Also, I'll put in that that's all done, automatically behind the scenes. So there's no like knobs or dials or anything for customers to change for you. That it's just you set it up, and our system will go in and do the rest.
All right, so I think let's go ahead and get wrapped up and let everyone kind of get back to their busy days. I would like to thank our presenters again. Gonzalo, Ross, and Taylor, thank you so much for your presentations. If you have any additional questions, we'll be reaching out to you separately over the next several days. We will be sending over a copy of the recorded version and the PowerPoint slides as well. And we very much thank you for your time, and have a great day.